Chemical characteristic properties. We find them in fireworks and northern lights. They're based on chemical properties of substances. Every gas in the atmosphere gives off a color that is unique, and that's why it's so special when it's in contact with the sun. And metals and fireworks also give off specific colors when they're burned. So, a chemical characteristic property, it's a unique property of an element or compound that makes it react with other substances in a very special way. You can identify the element because of its unique property. So, like example, if, pyrotechniques, so the art of firework, basically, they use metals that will give off a color when they're being burned. So, for example, if I look at white, this would be magnesium. And then the red ones are probably a metal called strontium. But we'll be looking specifically in the class for three gases. We're looking at oxygen, and that's the first test that we'll be testing. For oxygen, will keep a flame alive. So if I place a glowing splint or a glowing piece of wood that is I just barely, it's barely glowing, it will reignite again on fire. Hydrogen, the test that we use for that one is called the lit splint test. And that one will create a little popping sound. Actually, hydrogen is one of those elements. Actually, hydrogen is one of those elements that will uh, actually create a bomb, and that was the first atomic bomb was made of hydrogen. Hydrogen is also very powerful, is being used in the fuel to launch spaceships in outer space in 8 minutes. So you see, it's very strong, it's very powerful, full of energy. At the same time, it has destructive properties, but at the same time, that's what water is made of, right? With hydrogen, when we say H2O. So it's really unique element, and we can talk about hydrogen by itself for a good hour. Lime water is another test, very unique to carbon dioxide. Lime water is composed of calcium, oxygen, and hydrogen. In fact, the chemical name is calcium hydroxide. And that one, when it is in contact with carbon dioxide, it will actually create chalk, like a milky looking liquid. And lime water has nothing to do with citrus. There's no lime or lemons or anything like that. It's just a term used in chemistry for substances that contain hydroxide, O and H together. We can take a look at this video quickly together. Let's see the demonstration. So the first test you'll see is that famous lime water starts off clear, and when it's placed in a test tube filled with carbon dioxide, it turns to a white color, as you can see. And that is chalk that's in suspension inside the liquid, which is really neat. The next test is for oxygen. As you know, oxygen, we need it to start a fire. If you have a candle and you stifle it, it will blow out. So there, you see how we place the stick inside and it reignites the flame, which is unique to only oxygen. So long there's oxygen, it will keep on burning. And the last test is the hydrogen test, the lit splint. So this way, this one is actually, we keep the fire going, and as we approach it to the test tube, woo, it will pop, make a popping sound. Some pretty powerful stuff. Okay. Next are the liquids. So we'll be testing for acid thanks to blue litmus paper, and it'll turn red, as you know, for an acid. What about red litmus paper? We'll be testing for a base. What color should that turn to will that turn to if the red litmus paper is placed inside a base, such as Windex or soap? Yes, it'll turn blue. And a third test we'll be looking at is a cobalt chloride test, which is unique because it will test only for water. This is a new test, so it turns from a blue color to a pink, almost white, and that detects water. Iodine test will test for starch, and as we had seen it before, it will turn to a blue black in presence of iodine. Last but not least is a very colorful bromothymol blue, which is again will test for acids and bases, neutral substances. And when the bromothymol blue is placed in an acid, it will turn yellow. In a base, it'll be blue, and green in a neutral substance. So, what is the nature of this first liquid over here? Yes, an acid. Good job. What about over here? Neutral, because there's no change. And last, a base. Good job. Here's that famous cobalt chloride test. Which of these was dipped in water or a substance containing water? Yes, this one right here with the light pink. That's the only one that detected water. Here's that famous starch test. The iodine starting off yellow, and when it's placed with starch, it will be a blue, even darker than that. It's that famous carbon dioxide limewater test. And last but not least, that really colorful bromothymol blue, how we go from yellow in acids, green in neutral, and blue in bases. Thank you. Have a nice day.